Alright, just want to make sure that you guys can hear me okay. Is everybody can hear me? Awesome. Okay, so it's been a while, right? It's been quite a while since we've actually had a class. Like almost, 3 weeks now, I guess, all in together. Well, if you don't include the test, yeah, almost a month. Let's see, we had reading week, and then there was the big hack that happened at Lakehead. By the sounds of it, they're still resolving issues from that. And then our test, which was, remote, but there was no real reason to have like a class discussion about it. That also actually brings up a important notice that I need to give you, which is the final. So the final's been scheduled. So this is unusual for me because usually I just do it in the last class. So whatever the last class is, I book a final and we do the final during that last class. However, Lakehead has kind of a different way that this is done. So the way they do it is they schedule a final, and then that final is, then we do the final during that scheduled time. And this time it happens to be 1 o'clock in the afternoon on a Sunday. April 18th is when it is. So I did post an announcement. I sent it out to everybody. So hopefully you got that announcement. Make sure you put that into your calendar. Because unfortunately that's when we have to do the final. That's just the way it's done. Even though I'm not using any exam proctors or anything, and I'm not doing anything out of the norm, it's still going to be pretty much the same thing that we just did for the midterms. So I don't know, but I have to follow whatever the rules set is. That means also that the days before that one, let's see here, let's jump a month here. Okay, so that's the 18th of the Sunday. We have a class on the 12th, so you will have a class on the 12th. So that's 1, 2, 3, 5, 6 classes left. Yeah, that's about right. That makes sense. Yeah, so we have 6 classes and then that final. So you'll have a class that week plus the final, which is a little annoying just because you'll have to, that class that week will be on the final as well, so you'll have to make sure you study that last class as well. But yeah, any questions about the final at all? If for some reason you have to change the time for your final, you'll have to contact your program coordinator and they'll let you know how to go about that. I know at Georgian, if we have to change the time of a final, you have to go through the test center. They send me some stupid form that I've got to fill out, and then I send that form back to them, and then you schedule a time for you to actually take the test. The one thing I will say, though, is I like to do these open tests where you have open internet, open book, and you can communicate, and they shut all that down. So I've had students in the past take it at the test center, and even though they have a written thing from me saying that they're allowed to use their book and the internet, they won't allow it to happen. So if for some reason you have to do it at the test center, just keep that in mind. All right, cool. So Away's actually asked if I wouldn't mind taking up the test this week, and I don't mind. I don't generally do this. This is unusual, but this is the only semester I'm teaching JavaScript frameworks in. Next semester, I'm actually taking it off, and I might actually take it off permanently. I might not come back. I just had a change in roles at work that pays considerably more. But that's not the only reason. It's just, I work so much, it'd be nice to have some time off. So anyways, I don't mind taking this up because it's not likely going to wind up in some future test somewhere on somebody else's plate in the future. So, so for the most part, I did mark all the tests. I didn't encounter anybody that seemed to really have any problems. I don't even think anybody really got that low of a grade. I think for the most part, everybody was pretty much 80 or higher. A lot of you wound up with bonuses because you completed the filter or you completed the sort. If you completed both, I gave you a 20% bonus. Some of you completed just the filter, or some of you just completed the sort, or some of you didn't do either. So, which was fine. Which I said to you at the time was fine. I'm not going to take up how to implement the filter or sort. I don't mind taking a look at the other pieces. So the things you had to do was kind of like a multi-level kind of exam where you had to you had these base instructions, and if you wanted the remaining instructions, you had to get at least these base instructions done, right? Otherwise, it wasn't going to work. Can you guys see my screen okay? Like, you can read this? Is it Big enough, or does it need to be bigger? It's good? All right, cool. So I'm going to put the instructions over here, and then I'll do the code on the other side. So you might be like, hey, you know, it took us 2 hours to do it, but watch this. I can do this so quickly. Because I wrote it. That's really what it is. All right, so get your application running in the browser. Well, obviously, we need to open this up in a browser. So this is the student test portal. This is the same thing, or posts that you guys downloaded. I'm going to open git bash in here. And so the first thing I noticed that I had quite a few students ask me, Sean, this isn't working. It won't run. It keeps telling me there's a React scripts error. What do you do when you get the React scripts error? First of all, does anybody know why you get the missing React scripts error? Yeah, you can install React scripts, but what's the better thing to do? I've already given you a package JSON file. Yeah, just run yarn. If you run yarn, it installs all of the node modules that are needed for React. They'll all get installed. I already have it in here, so that's why it goes super, super fast. But it'll install all those React scripts for you, and you're good to go. The next step is yarn start. All right, once yarn start runs, it should boot up our browser window. And if you have the... so now I'm one step ahead because I was actually dealing with a student that day. So I already have the instructions installed. So that's kind of... That's on me. 1 second. Let me get rid of them so you can see what I did. Yeah, so you guys had... There we go. That's what yours looked like. So when your page would have loaded, you would have had this. Would have been a broken page. Right? Super broken. Some of you had your console open so that you could see what was going on. You had these big error messages, and you guys were asking me, and some of you asked me the question of, why am I getting this error message? Well, you're getting this error message because you need to complete this component, right? And this is not what the components look like. One thing that should have been the absolute giveaway is you can't have a return statement in just the open script, right? It has to be contained within a function, and that's true literally for every programming language. I can't think of a programming language that doesn't have that as a fact, right? So the fact is this has to be in at least a function call, so that should have been the trigger hint for you to actually create the component around it. So I'm going to create a component around it. Boom, there's my component. Right? And now you should have at least had a working page. So it says instructions is not defined. That's because I have instructions in here. But I don't think you guys had the instructions in there yet. I think it was just like that. Which means you should have had this. Home sweet home. So your next step, looking at the instructions, is to import the instructions component into the home component and add it to the render in the indicated spot. So I think there was a comment in here at one point. So we imported the instructions from shared, and you would have had to go find it. Is it instruction? It's instructions. Why is it being so weird? Yeah. Oh, because I spelled from wrong. Duh. There we go. And then you had to actually render the component. So I think I had one student that kind of messed this up, but still managed to make it through somehow. Instructions is not defined. Well, that tells me that I spelled the thing wrong. Yay! So now you have your instructions. And I even gave you these little check boxes that you could check. Did anybody look at the code for that so that you could see how that was actually highlighting? I had to create a little component to make that happen. All right, so add the data component to the routes. So you guys would have had to go to routes, right? The data component, maybe it was already imported. I'm not sure if it was, but if it wasn't, there it is. And then you would have had to add your route, which really you could have just Alt-Shift down, Call this data. Call this data. Save it. And then you should have had your link, which would have connected you to the data table. And zoom this out a bit. Now, one thing to note, a lot of you said to me, hey, my API isn't working on Netlify. It actually was. I marked so many of yours, and you said that you were missing data. No one was missing data. Everybody had data. What I think was happening is a bunch of you gave me this link with /data. If I go to that link, it's going to work locally, but if I go to that link on Netlify, it actually breaks, and it gives me a not found. I have to go to home, and then it works, and then from home I can go to data, and everything worked just fine. So just keep that in mind if you're getting that weird API thing in your projects that we're due today. Just check and make sure that's not the case. Start at the root of your application, click on your data link, and then go see if the data is there. Okay, so I've got my data connected now, but I need to finish off the rest of it. So this is done. We're done with that. I'll dock this over to the side. What's my next instruction? Using the provided API link. That was another catch. And a lot of people said, hey, where's the API link? Well, the API link was this thing on the data page in the index.jsx. That was your provided data link, right? So I gave you that already. So we've done this one. We've done this one. Create a table that will display the data. So I gave you the basics of the table. You just needed to be able to display the data, but you also needed to finish this Axios piece. So you're going to need a hook, right? So you would need use effect. You're going to need a place to store the data, so you're going to need use state as well. So you would have likely created a data set data state, and there was no existing data to store there, but you could put an empty array in there. That would have been valid to do. And then you wanted to use effect. And you have to put in these brackets at the end, otherwise what will happen is the Axios call will keep happening. You needed to import Axios so that you could actually make an Axios call. Whoops. And then you could go through that process. So it's just Axios.get API link. Nice and easy. .then, which would have given you a response, to which you could have just set the data as response.data. And then now you have your data actually inside this state variable, and now you can use that state variable below. So let me delete the sort and filter, because we're not going to implement that just because we have a regular class still to do. There we go. So now that you have the data, you would have had to iterate over it. And some people made the mistake and put like the iterator in the wrong spot. Somebody did a weird thing where they just flattened it all so that it was all in a big string, and then they just spit out the string. If that was you, you'll understand why you kind of lost some marks for that. I expected it to be in the tabular form, right? So this data is here. I can't remember what the fields were. I want to say that they were user ID, just regular ID. I think there was a name field, and was it post? I want to say user ID was one of them. I mean, we can always look, right? I'm making this a lot more complicated. We can actually literally just go data. And we'll go home and then data. There we go. User ID title, that was the other one. Ah, right, because it's a post. So it was title and body. There we go. Let's get rid of that. Cool. So we have it all there. Now we can just go ahead and iterate within the body. So you want it in rows, right? So you need to wrap the row with the actual iterator. So what I like to do is I first put in my my curly braces, which signifies where I'm going to write JavaScript, right? That's the way we write JavaScript inside our JSX file. And then I'm just going to iterate over that data. So I'm going to do data.map. And it's up to you what you want to call it. You could call it post, right? And then in here, so that will return the post. Data.map post. What am I doing here? Right, I need a set of parentheses so I can actually block out the pieces. And then I can write my TR. And then my TD. And then these TDs can have those data pieces in it. Is it Alt Control up? There it is. And there we go. And so all of that would have gotten you 100 points. Right? So that would have given you the mark of 100. Any questions about that test? No? Did you guys find it hard? If you did the bonus but received 100, it is possible I might have missed it. What I did in order to test the bonus is I would click on the user IDs, and if things sorted, then you would get your 10. And then in this one, I would type QUIA, and if this list moved, then I would go ahead and give you that 10% as well. If that's the case, Sky, just send me an email, and I'll go take a look at it again, and then give you the bonus for it. That's fine. Yeah, just send me an email so I don't forget. Otherwise, I forget. I know I always say, send me a Slack, right? But when it comes to things like that I need to check later, email's actually better for that. All right. Other than that, if there's no questions, cool. That was the test. Let's get into today's lesson. So, the good news is, well, I don't know if it's good. Some of you, I think, probably like React. I think some of you absolutely hate React. But the good news is, no more React for the next at least 4 weeks, right? No more React for 4 weeks. If we do any React whatsoever, I'll be providing you the React question, but that's it. Yeah, sure, Sky, that's totally fine. So, how does this work exactly? We're going to actually do Node.js. So the idea of this course is to think about systems as their own self-contained piece, right? So our React front end can live on its own. It can live in another computer somewhere else. Like, for example, at LMG, where I work, we have front-end applications. We have websites that are front-end applications. They all live on computers in Toronto. Actually, all of our system lives on computers in Toronto. But they live on their own virtual box, right? So they exist in their own virtual container. You can just think of it like its own little computer, right? So they each individually live on their own computer. And when they need data, they connect to a REST endpoint. And that REST endpoint provides them data. The REST endpoint lives on its own little box as well, right? So that's where all of our data exists. And then we have databases, and they live on their own box. And we have an emit panel for actually, entering new data into the system, and it lives on its own box. And this happens for 8, 9, 10, 11 different brands that we have that have this kind of basic setup, right? So I figured that because, LMG works like that, when I worked at G-Shift, we worked that way at G-Shift as well. Other companies I've seen that I talk to friends with that are working at those other companies, like Jane.com, even Amazon, even Google. I've got a buddy who works for Facebook, and same idea. They're all in these little individual systems that are encapsulated based on one idea, right? So you can think of the React side of our course as being that first little encapsulated piece. Why was it encapsulated? Because it doesn't really need to care. It doesn't need to care that that there's a REST endpoint or that the data comes from the REST endpoint. It just needs to have the data. It doesn't really care where it comes from. Whereas our REST endpoint, which will be our data layer that we're going to create, it doesn't need to care about the front end. It doesn't care who consumes it. It only cares that it has it and it can deliver the data. That's it. So we're going to build these things as separated pieces. We've done our React side. We've built out a bunch of React things, right? So that's separated. Now we're going to start taking a look at building out the actual data layer. So that's why the last class of React was working with APIs. We're essentially going to build our own API. I'm going to use the word REST quite often when we talk about this. REST is a style of API. There's also something known as SOAP as well. SOAP's pretty much dead and gone, but REST is very strong and still fairly common. You guys had a little bit of experience with working with MVC. MVC is definitely the foundation to working with REST and understanding REST. But REST essentially stands for Representational State Transfer. And basically what it is it's an interface, right? It's an interface to functionality that you can use that has already been predefined by just making requests. So you make a request to this, it's usually a URL, right? You make a request to a URL, or sometimes we call them endpoints. You make a request to that URL, and then that URL, based on your request, will return information to you or execute a function or do some sort of operation. That's the idea. So we're going to build something like that. Before we do that, we need to kind of understand Node a little bit. So we're going to work in Node today. And we also need to very much understand blocking versus non-blocking. And the reason why that is once we start getting into input and output operations in JavaScript, that's when we start to really experience the asynchronous nature of JavaScript. So anything to do with I/O, whether it's file writing, whether it's making requests to a database or making requests to an API endpoint, receiving user input, so clicking, changing text in a field or anything like that, all of those things are considered I/O operations, which stands for input-output, and any of those operations are non-blocking, meaning that it's not going to wait around for the user to input information before it starts to execute other lines of code. So I have a small example of this that I like to demonstrate so that you kind of get a better idea of how this works. Let's do the demonstration, and then I'll show you the little diagram for it, and we can talk about it. So let's here, get rid of this thing. We don't need that right now. Let's open up our live lessons that we've been working on. And we're going to create a new folder in here. And I'm going to call it lesson 6, I want to say. Yes, would be lesson 6. And then once you've created lesson 6, go ahead and right-click and choose to open it up with your code. Or open it up in your code editor. So you're creating a lesson 6 folder, and you're opening up that folder in your code editor, and we'll add some files into it. While we're at it, we'll also open up a terminal, right, with inside that folder. And we're going to install something new that's going to make our lives very easy for working with Node. First thing I think we should do is just create a very simple JavaScript file. We'll call it new file, and we'll call it itworks.js. And all we're going to write in this file is console, right? So that's how we output to the console. .log hello world. Or you can just write it works. That also works. So the console, just this term that you see here, whether we're writing code for the front end in React or writing just a plain JavaScript file in our browser, right? Which you've seen before, where you can actually write console in the browser itself. Hopefully you guys have seen this before. F12. This thing here is your console window, right? You can write statements in here, and you can write console.log, hello world, and it will output hello world in the console. This is your link to something called standard out. And what standard out is for actually outputting information to whatever the running process is. And the running process usually will output whatever data you're telling it to output to its running shell. So in this scenario, our browser, it's outputting to this console window. That's where this running process outputs information. When we're working in Node, it's going to output its information into our terminal window here that you see here. So whatever you're using for a shell, it's going to output that information into the shell when we execute the script. So to execute the script, we already have Node installed, or you should. Let's just double check and make sure. So we're going to type in node-v and hit enter. And if you have Node installed, you should see your version number. It doesn't necessarily need to be the same one as me. As long as it's version 12 or higher, we're okay. And as long as you can see that line there, if you don't see that line, you're going to need to go to your browser. And you're going to need to go to Node, the website, and download Node and install it. But I think you guys should be good. I think you all have Node. I'm pretty sure we tested all that and we fixed any issues at the time. To run this script, we simply call node space and then reference the script itself. So we just need to, if I start to type IT and I hit tab, because I'm in the directory, I should be able to see itworks.js. And if I hit enter, it's going to execute that code. This console is going to tell it to output information through the standard out, and the standard out being our shell is going to output here in the shell window. So we get to see hello world. Incidentally, if you're just trying to a little piece of JavaScript and you just want to know if it works or not, and you don't feel like, writing a whole script inside a file, you just want to output something, you can also just type node in your shell and hit enter. This will give you essentially the same thing as, where is it? Where's my console window? Oh, I closed it. This will give you the same thing as this. Essentially, these two things are basically the same, only this is server side, this is client side. But this will give you a little shell that you can actually type in code for Node and see if it works. So in here, I could type in console log, hello world, and it will output it here. To disconnect from this, I hit Control D and it disconnects. I think if you're in PowerShell, here, you know what? Let me try, just because I know some of you are using PowerShell. I think in PowerShell, you just hit Control C and hit it again, and it will disconnect, or you can hit Control D to disconnect it. Either one of those will work. All right, I can't hit Control L, which is so frustrating. All right, is everybody's working so far? Are we all good? Thumbs up. Nice. All right, let's talk a little bit about blocking and unblocking code. So I'm going to create another file here. So a new file, and we're going to call it BLK versus NBLK.js, or whatever you want to call it. I don't care. I'm using blocking versus non-blocking. I called it this. That's what I named my file. So the first thing I'm going to do is create a function. Hopefully you guys still remember how to create functions in JavaScript. Whoops. I don't know why I deleted that. Function, say hi. It's going to take one argument called name. And all it's going to do is output hello name. So I'll use a string template here. Maybe we'll use some punctuation. Hello name. Very simple function. If I type in node blk, what do you think will happen? Will the function execute? Leo says nothing. Does anybody say something else will happen? No? Nobody's as adventurous? Nobody wants to contest? You are both right. Nothing will happen. And the reason is because it's a function and we haven't actually executed, right? If we want the function to actually do what it needs to do, we need to invoke it. So let's write a little bit of code that will allow us to invoke it. Say hi. That's our function call. Give it a name, right? There we go. Save it. And then press up on your keyboard because, I mean, we're lazy programmers and we don't want to type in node blk versus nblk each time. Hit enter and you should see hello and whatever your name was. Now this whole idea of having to hit up, enter each time I want to do this is a little bit tedious. So there's another way we can do this and just have it run all the time, and that's called Nodemon. Now here's, or Nodemon, depending on what you want to call it. I consider it's Nodemon because it is a demonized process that's running, but anyways. The only problem I've had with installing Nodemon before with students is that it doesn't seem to work on everyone's machine. Sometimes I have issues where they can't get it to execute and do the things properly if they install it globally, but they're fine if they install it locally. Okay? So if you can install it globally and it works, yay. If you can't, you can always install it locally. So what we need to do to install it is just npm. So you remember that package manager we talked about way long time ago, like second class. npm, which stands for Node Package Manager. Install, so the thing I want to install. -g, which is a flag to say install this globally. Nodemon. So I will copy that and I will share that inside the chat window here. There you go. Hit enter. And that's going to install Nodemon at the global, within my global node modules folder. The issue that some students have is to do with permissions, and they can't seem to install things globally because for whatever reason their systems are fairly locked down. You guys being in a computer science program need to figure that out. My Georgian college students, nah, not so much. They can always take it to the IT guy and he can figure it out. But you guys in a comp sci course, you should learn to figure that out. Once you've done that, what's cool, all you have to do is run nodemon and the name of the file that you want to listen to. So I'm going to blk versus nblk. And if I hit enter, now what happens is this listener is going to listen for file changes. And when the file changes, it will execute the file and then continue listening. So if I say Leo here, you can see it says, hello, Leo. And if I change this to Nick, it says, hello, Nick. So it auto restarts itself, and I don't have to constantly type in node and whatever the name is. So let's talk a little bit about what blocking code is. Blocking code is code that literally blocks one line from executing before it has executed. So say hi, Nick. This code is currently blocking. Any code I enter in afterwards will not execute before this code executes, right? So line 6 will not execute before line 5. Hello, Nick. Hello. This isn't a timing thing. This is just how this works, right? Most people who start with programming, they kind of expect this because we start with a lot of, we tend to start with process-based programming languages like Java or C#, C++, or even PHP, right? PHP is a big one too. JavaScript, most code is blocking. Like a majority of the things you're going to work with are going to be blocking code, where it's one line at a time. It's only when you start working with input-output, or you're working with any of the set timeout, set interval things that are built into JavaScript. So let's add a few people in here. There we go. And as you can see, the order that we put the code in is the same order that the console's output as, right? No difference there. Totally blocking. Line 5 blocks line 6. Line 6 blocks line 7. And off we go. One thing to note about JavaScript, though, is functions and variables are automatically hoisted, meaning that they're taken from wherever they are and hoisted to the top level. That's only variables defined with the var decorator. If it's not defined with the var decorator and you've used const or let, then that's not true. They don't get hoisted. But functions, like this function you see here, are hoisted, which means if I take this function and put it down here below these, it will still work. And the reason is because as this script is being processed, this function call is automatically found by the interpreter, taken from this location, attached to the global object automatically, and then the script is interpreted, allowing these to invoke that, right? So this function does not necessarily have to be above these. It can be lower in the list. Because of that, it is a common thing you will see in JavaScript where people define their functions below their code. So if you're looking at somebody's JavaScript and you're like, how the hell does that work? The reason is because the interpreter hoists this expression way up above, and therefore it becomes available to anything invoking it. So this is blocking, right? All this code is blocking. Line 1 blocks line 2, which blocks line 3. How do I do it so it's non-blocking? Well, like I said, when it comes to input-output, JavaScript does not block that code. It also doesn't block code for things like intervals or timeouts. So it won't wait around. It will just go, okay, cool, I will execute that once I'm done. But I'm going to continue on with the rest of this code, and then I'll come back when you're ready. So for example, set interval, I'm not sure if you guys have experience using set interval. Set interval takes 2 arguments. It actually takes 3 arguments. Well, it takes an infinite amount of arguments. The first argument, though, is the function you want to execute after a certain period of time. So the function I want to execute is say hi. Now you're not giving the parentheses, because if you give the parentheses, you will invoke the function. You don't want to invoke the function. You just want to pass the function definition. So you're literally, it's almost as if you took this code and just dumped it right in there. That's what you're doing. You're passing this function call into here. It hasn't executed it yet. Then you want to give the second piece, which is how long you want to wait before you execute that function. Now that's the important thing about set interval that tends to throw people off. They assume that it invokes the function at second 0, which is not true. It invokes the function for the first time once it reaches the interval timeout. If you want to invoke the function at second 0, you need to actually call the function above set interval and then let set interval take its place. So that's important to note. So I want to do 25 seconds, right? Or sorry, 2.5 seconds. So I'm going to give it 2500, which stands for 2.5 seconds because it's in milliseconds. And then the last set of arguments that we can pass, which can be any number of arguments that we want here, is the arguments that we're going to pass into the function. So it's a list of arguments that we want to pass in. So I'm just going to use, who else is in my list here? Not to call on people, but there you go, Jessica. And then I'm going to wait to 5,000, which is 5 seconds. And we'll call Magnus. All right, so once I hit save, it's going to say hi to Nick. It's going to say hi to Sky. It's going to say hi to Stella. It's going to wait 2.5 seconds and then call Jessica. And then it's going to wait 5 seconds and call Magnus. So, out of curiosity, looking at this code, at what point, like how many seconds will have passed before it says, hello, Magnus? So Leo says 5 seconds. Does anybody else want to factor a guess? Magnus says 5. Does anybody disagree? Does anybody think it's 7.5? Awesome. You're about to guess that? So Sky thinks it might be 7.5. All right, so let's save, and we have to start counting right off the bat, right? So 1, 2, 3, 4, 5. There's Magnus. There's Jessica again. Now you'll notice that it keeps outputting these, and that's because it's set interval, so it will literally be outputting every 2.5 seconds Jessica and every 5 seconds Magnus. Yeah, so the reason why you were incorrect, Sky, was because what actually happens is the interpreter comes through, it sees this set interval and says, oh, okay, so once I hit 2.5 seconds, I will execute this function. I will invoke this function. Then it sees this set interval and it says, oh, okay, well, once I hit 5 seconds, I will invoke this function. Meaning that it doesn't add them together, it actually just implements them once it's past that time threshold. So at 2.5 seconds and at 5 seconds. These, by the way, are not reliable. Not even a little bit. If there's a blocking process that is taking a lot of time on the CPU, it can cause these time frames to be inaccurate and not happen. So do not rely on them. For example, if you were using them to say, I don't know, do animations or something like that, these are not the best use for animations. There's much better scenarios that you can use things like deltas in order to handle animations. This is pretty much terrible for animations. But it does kind of show our scenario. So let's show it a little bit more. So right now, you might be like, okay, well, that's fine, Sean. You know, you put this line first, you put that line second, you put that line third, and then you had these two guys after. So how does that show that this code is not blocking? Well, let's take a look. I'm going to change these, though, from set timeout to set interval. Or, sorry, from set interval to set timeout. And the reason I'm doing that is because set timeout will actually cause it to only invoke once. Set interval will happen on intervals. Set timeout will delay until the time threshold is met, and then it will execute the function. So I'm just going to clear my screen here, run my Nodemon. So there's Nick, Sky, and Stella. There's Jessica. There's Magnus. So as you can see, it executed Nick, Sky, Stella, then Jessica, then Magnus. Well, what if we start manipulating these a little bit more? And we'll put them through like this, right? So it's going to say Nick, and then it's going to set up the set timeout, and then it's going to say hi, and then it's going to set the set timeout, and then it's going to say hi to Stella. But maybe this will change everything. Maybe because this one blocking line here is here, it might mess this all up. Nope, looks like it's going to happen the same way. There's Jessica, there's Magnus. So like I said, though, this is a common scenario when it comes to using set interval, set timeout, but the biggest common scenario, because you will use set timeout and set interval if you wind up coding JavaScript as a career. They are common things that you will be using, especially if you're trying to do like sleeps and stuff like that. But the place where you're going to really notice it is when you're working with input and output. So any input and output, reaching out to APIs, writing data to a database, writing data to a file, right? Taking input from user interactions, right? Or any type of event-driven stuff, that's when you're going to really notice it. So I did create a nice little diagram here that talks about this in exactly how this actually functions, because it is an interesting idea. For those of you that like to look a little bit more under the hood at things, one of the things about JavaScript that's kind of essential to know, because a lot of people confuse this capability. They think the reason why JavaScript is able to do this is that it has one thread running for all of this information here for line 1, line 3, and line 5. And then it starts creating a new thread for the set timeout to manage that timeout, and creates another thread in order to deal with the second set timeout, right? So every time we want to do one of these asynchronous operations, it just creates another thread and another thread and another thread. But your computer has limits, right? There's only a limit. There's a limit to how many threads, processing threads, can be created. And it is quite high, but there is a limit. That's not how JavaScript works, though. JavaScript is a single-threaded, asynchronous language. And the reason it's capable of doing what you see here has nothing to do with creating multiple threads, because it's not what it's doing. It has to do with this wonderful magic thing called the event loop. The event loop is really, really awesome. What happens, essentially, is we have a stack of events that we're executing. So each statement we make gets attached to the stack, and when it can process that statement, it does. So the way this happens is say hi got added to the top of the stack, set timeout got added second, say hi sky got added third, set timeout got added fourth, and say hi Stella got added fifth. So these all wound up into this event stack. The event stack processed through, found say hi, executed immediately, and responded with it. Then it hit the set timeout, and it says, oh, you're a long operation. And you're not ready to be completed yet. I'm going to add you back to the stack, and I'm going to move on. So it moves on, and it hits say hi sky, and it's like, cool, I can execute you right away. So it executes it immediately. Then it gets to this one, and it says, oh, you're a long-running operation as well. I'm going to add you back to the stack, and I'm going to move on. Then it executes this one and says, say hi Stella. Then it goes back and checks the stack. It still has this guy in the stack, so it checks to see if it can execute it. Not yet. So it moves on to the next one. Not yet. And it keeps doing that till it finally reaches this timeout. Then it says, oh, I can go ahead and execute you. So it executes the set timeout, executes say hi, and then it comes down to the Magnus one and checks to see if it can execute that one yet. Nope. Goes back around until it finally hits the 5-second mark, and then it executes it. This pattern that you see here, as much as it's only in JavaScript, I have seen this pattern implemented in other programming languages for this exact purpose, right? To be able to deal with these kind of issues of not wanting long-running operations where you're waiting, but being able to move on and execute other code and then return back to this code when you're finally ready, right? So I have seen that before in different types of programs where people have implemented their own event loops. So the event loop is kind of an interesting idea. It does lend to the fact that you do need to understand something called callbacks, right? And we've been using callbacks quite a bit. You just didn't realize that we were doing it. Often we call callbacks higher order functions as well, right? So a callback is essentially a function provided to a function, right? So we call a function and we give it a function. And then when that function executes, it calls our callback. So why don't we create a new file called callback.js. And then we'll attach Nodemon to it. So we'll create a function here just called farewell. And we'll give it a name as an argument. And all it's going to do is console log goodbye name. And then we'll create another function called greeting. And it's going to take 2 arguments, a name and a callback. And it's going to output console log hello name. And then once it's done, it's going to call the callback function and pass it that name argument. Okay. So farewell, just a simple function. All it does is output goodbye and then whatever the name is. Greeting is a little bit more complex. It takes a name as one of the arguments, and then callback, which will be a function. So just a function definition, almost literally as if we copied this and replaced the word callback with this whole description. Once we've outputted hello name, we can go ahead and call our callback and pass this argument all the way through into name. So let's see how that would work. So if I call greeting, I'm going to give it name, and then I'm going to give it I'm not going to give it name, I'm going to give it my name. And then I'm going to give it the callback I want to execute, which has to be a function definition. So you know what? I've got a function that's perfectly usable up here. I'll just give it farewell. And notice I'm not adding the parentheses, because if I add the parentheses, that invokes it. I don't want to invoke it. I just want the actual definition of it to be passed. So once that definition comes in here, it's literally as if I took farewell and executed farewell name. So now if I save, we got hello Sean, goodbye Sean. So that's a confusing one for a lot of people. That's why I have this really handy diagram on it. And the diagram, as you can see, here's our function greeting, right? And I've passed in Sean McKinnon, and I've passed in the function called farewell. This is the function definition that I'm passing into here. When I pass that into the callback here, the callback winds up getting executed. So if you follow these green lines, you can see that callback is really just our farewell function getting called. So the benefits of callback are as follows. Code separation and modularity, right? So we can have a greeting function, and the greeting function doesn't need to care about farewell. It doesn't need to care about literally anything at all, because all it cares about is that it's receiving this function and then it can execute that function. It doesn't matter whether it's called farewell. We could call it something completely different and it could do something completely different, right? But this is going to execute it and it's going to pass that name function in. And then when it executes, we wind up getting the benefit of these modular functions being called, and we can literally pass in any other callback function at any point if we choose to. We also get priority execution, so it can be executed when needed, which is more beneficial than asynchronous. So this is one way to thwart asynchronicity. We can provide a function to our callback, and if this was an asynchronous function that happened on its own timing, what would happen in this scenario then is farewell will get called once the asynchronous nature has ended. And then it also provides an order of operation structure where one function can invoke another of it once it's been executed. So callbacks you guys have already been working with. You may not realize it. Like for example, so I've got abc.map. And guess what I'm going to give this? It even tells you a callback function. Now the cool thing about map, you don't actually see this function definition, but this function definition is not much different than this. Essentially what happens in the map function is map would actually have two pieces. It's going to have the item and it's going to have the index. So when you call map, and you call this function, it's actually going to take whatever callback you give here, right? So it has its callback. Sorry, it actually looks more like this. Like so. Map is going to call your callback, And it's going to pass an item and the index into it from your array. So that's essentially what's happening under the hood. So you, in your callback, can actually access those items that the map function is already passing to you. That's how we get that functionality that we've been using before. So I know this is confusing, and I don't expect you to get it right away. And I'm never going to ask for that on the test, so to speak. Most of the stuff we're going to do is just going to come as second nature to you anyways, so it's not a big deal. This stuff gets a little bit more complex, and it is things that you will wind up using over time. But for the most part, we're going to be using async and await like we did in React. No, we didn't actually. We didn't use async and await. We're going to be using async and await, which is a lot simpler than working with the asynchronous operations. So let's take a small break. When we come back from our break, we'll take a look at using... or do we want to do that? You know what? I'm not going to make any promises. Let's take a small break, and then I'll see where we're at in this lesson to what I want to actually introduce next. All right? Any questions about any of that stuff out of curiosity? Did you guys do callbacks in your JavaScript intro class? I was going to say, because you guys seem pretty familiar with it. Who did you have for your JavaScript teacher out of curiosity? Oh, you guys had Jessica? Okay, yeah. I know that Albert does it. I wasn't sure if Jess did too. Yeah, awesome. That's awesome. All right, let's take a small break. We'll come back at 4:10. All right, we're back. Let's move this over here. This screen is really big. Let's shrink it down a little bit because it's a little much. Okay, so I was going to do. I have like this one, like small app that I build with you guys, that basically just shows something called Callback Hell, which is where you have a callback that also takes a callback. That also takes a callback, and you wind up with all these ridiculous amounts of callback. But I figure, you know what? If we don't look at it, maybe you guys will be smart enough never to actually do it. So once I introduce async and await, it should be your last resort anyway, so you would never likely touch it. So we're going to do async and await instead. There we go. So the first thing we're actually going to do tonight then is a super simple Node server using something called Express. So this is how we're going to build our APIs. We're going to use an application, a module. It's another NPM module called Express that will allow us to set up a very simple web server, essentially. Express does more than just give us a web server, though it actually also gives us routing and a whole bunch of other extra things, middleware and stuff like that, but we'll talk about more about that in a bit. All right, so what is Express? Well, Express, or Express.js, is a minimalistic web framework that provides several helpful features to create a website, right? So you can create websites with it, or a RESTful application. Just like PHP, Express can be connected to something that generates HTML, so they call it a view engine. You can connect a view engine. There is one that comes with it by default, called EJS or Express. It's not Express.js, but it's like EJS is like the templating language. But you can add others. You can do Pug, you can do just raw HTML, you can do Jade, Mustache, there's a whole bunch of them. So Express provides a way to create websites, or you can just build RESTful applications, so you could build like an API. So it provides an extensive routing solution, so just the same like the routing that we used in our React application, or the routing that you guys would have set up when you were building your ASP.NET sites. That kind of routing, Express provides a routing solution so that we can create routes. Express also provides a robust middleware solution. So what a middleware solution does is it performs operations on a request, right? So when a user types a URL into the browser and hits enter, it creates something called a request. That request goes off to the server. Express actually takes that request and passes it through different stages of middleware to where you can add other things to it or manipulate that manipulate that request, or whatever it is that you want to do to finally build out a response and send it back. So understanding each of these objects is fundamental to working with Express. So the three objects that we're going to work with in Express are request, response, and next. Request, this is the object that contains all the information pertaining to the request, including parameters, message bodies, headers, and authentication. So anything that the user is sending from their browser or from a curl request or whatever it is that it's coming from, that's our request, right? That's all the information that we contain in the request. The response, this is the object we use for actually responding back. And this can be HTML, it can be text, it can be a PDF, it can be XML, it can be JSON, it can be literally whatever we decide to send back. And next, what next is this function provides us with a way to be able to move between our middleware functions. So we can have our request go to a middleware, we can process it, then we can hit next, and then it goes to the next middleware. And it keeps doing that till we finally send back a response. So building an Express web application is fairly simple. The best thing that we want to do is to create a new project folder on our computer. Did we want to create a new project folder? No. You know what? We'll just do it in this folder that we're already in. So just kill your server, right? The Nodemon server that's running. And the first thing we're going to do is initialize a new npm or a new node project. So we're going to type in npm init, which stands for init, right? So npm init. And if you hit enter, it's going to ask you some questions. So first question is, what is the package name? Well, we're going to call our package name Chuck Norris. You'll see why in a moment. And what version is this? Well, we're super alpha, so we're going to call it 0.1.0. Description, best Chuck Norris app ever. Our entry point file is what file are we actually going to execute when we run our script. We're going to execute index.js. That'll be our main entry. Our test command, just skip that. We aren't going to attach it to a Git repository yet. We don't need keywords. The author, that's you. I'm going to put my name. You guys put your name. The license, just leave it as ISC. When you hit enter, it's going to show you a small JSON block describing all the different settings that you have in here. That looks perfectly okay to me. I'm just going to hit enter, and we're good. It's going to generate a package.json file, which you guys should be used to, right? We see these in our React application. This is where anything that we're doing is going to go. Any modules we install are going to get added to here just as dependencies, just like it happened in React. I just hit enter, Parth. I didn't actually set up a test command. We are going to look at this script section in a bit because we're going to create a new script and add it in there, but we'll talk about that in a moment. So the next step is I want to install some modules, and you can use Yarn in NPM. Once you have Yarn installed, you totally can use Yarn. I just prefer using NPM to show you both of them, right? Because we spent 5 weeks with Yarn. Let's spend the next 6 weeks with NPM. So I'm going to install three npm modules altogether. The first one I want is Express. So that's our web server. So we're going to install that first. So npm install Express. And it might take a few seconds to come down. I already have it, so it came down pretty quick. The next one I want to install is Axios because I want to make a request to an API endpoint and retrieve some data. So npm install Axios, and that will install the Axios module. And then the last thing we need to install is to deal with the cores issue, because what will happen is I want to access this from outside, but because this is a server-side application, so Node is server-side, React is client-side, because it's a server-side application, we need to be able to access it in some way. We can access it from the browser, technically, but it's more common to work with your APIs using some sort of API helper utility, like working with Hopscotch or Postman. It's not nmp install Stella, it's npm install. So it's npm install express. Or if you guys want to shortcut it, you can also do npm I express. That also works. Was that the issue, Stella, or are you still having an error? The mystery continues. All right, so the last thing we need to install is the cores library. So we can do that one by just typing npm I cores. So I'm going to do npm I cores. I is just short for install. And notice as I install these, our package JSON file is updating, and now we have a dependencies field. We have Axios, cores, and express. You know what we don't have, though? We don't have an index file. We need an index file. So let's right-click, choose New File, and we're going to create a file called index.js, and that will be our index file. So when we're creating our Express server, this is kind of the general setup that we're going to do all the time. At the top of our file, we're going to import all of the actual modules we want to use, but we're not using import, right? Instead, we're going to use something called require. So we're going to import Express or require Express. We're going to require Axios. And we're also going to require the cores library that we need. So far we haven't done anything. All we've done is require these modules. To create our actual app, this will be our web server, right? So we're actually creating our web server here, but we generally call it app. That's the common convention. We're going to call app like so. And we make it equal to express the function call. So we're actually executing the function. So that will create our application. We want to tell the app to use cores. So that will stop any issues with any cores related issues that we may wind up with. And then the last step is to create the app listener, which will actually listen for requests coming through. We give it a port number, so whatever port you want to listen to. Generally I do 4000. And then we can do console.log and just say, hey, we're listening on port 4000. Actually, let's clean that up just a little bit. I'm going to put a port in a variable here called 4000, and we'll see why later on when we start using Heroku, why I did that. I'm going to change out this console log a little bit to use a string template, and I'm going to say listening on port as a string template. So this is our file so far. So we've imported our 3 modules, right? Express, which is our web server. Axios, which we're going to use for actually communicating with an API called the Chuck Norris API and grabbing some information from it. Cores, which we're using to deal with any cross-origin request problems that we may wind up encountering. This actually handles that, so we don't have that issue. And then we create or instantiate, or however you want. Well, it's not actually instantiating. We're just executing Express, which creates a web server for us, and we're storing in this word app. We're doing app.use cores. This is actually called registering a middleware. So we can actually write that. Registering a middleware. And this is creating our web server. And this is listening for requests on port 4000. There you go. So those are the things that we're doing. This is importing our modules. Importing our modules. Now we want to run our server, and there are ways we can do this. So we can, it's just a JavaScript file. That's all it is. So we can literally run it the same way that we were running any of the other ones before. We can just type in node index.js, right? That'll execute this thing, and right now it's currently listening on port 4000. So that's good. Everything's working. I don't have an error, which is good. Or, because I want to modify this file, if I modified this file right now, it's not going to do anything. So if I come in here and do console.log hello world, notice nothing changes. Well, I can fix that by running Nodemon index.js, right? And now I can say hello awesome, and it will restart my server, which is cool. So that's another way that I can deal with that. But one of the most common ways to deal with creating a Node application is to actually create a start script. The way we create a start script is in our package JSON file under the scripts. We're going to press comma, and we're going to create a new script called start. And this script is literally going to just call some sort of command line operation. So anything you type in here is what you would put in here. So I'm just going to do nodemon index.js, just like so. So this is really cool because you can actually have start do a whole bunch of different things. And now over here, if I want to execute my script, I just do npm npm run start, or just even npm start. Either one will work. And as you can see, it executes that script, and it's doing the exact same thing that was happening with my Nodemon script. So under the scripts, under package.json, I just typed comma here. And then on the next line, I did start, nodemon index.js. By the time we're done our course, you're going to wind up with 2 of these. You're going to have a dev and a start. The start will be used for our production application, which we'll be storing on Heroku. And the dev side will be actually used using our local configuration. So we'll have 2. All good? Everybody still with me? Anybody lost? So the students last semester told me that they really, really liked Node, and they really, really, really hated React. They found Node considerably easier to understand. I like React too. I'm going to get rid of that console log. So right now, our application is doing diddly squat, and you can actually visit your application in your browser. I'm just going to put this up here, and I'm going to drop this guy down here. We can go to, here, I need this thing still. We can go to localhost, :4000. And you should just get this cannot get. But that's actually a good sign because it means that you're accessing your web server. This is being delivered by Express itself. So why don't we create a route? So the route will be used in order to access some sort of content. So the way we create a route is we have to build a route path, right? Just like we did in React. So the first way I like to start is I just like to type out what type of HTTP request I'm listening for, right? And there's a few of them. Hopefully you remember this. The two that we look for are gets and posts, right? Gets are for reading data, posts are for manipulating data. So just like in React, where we can actually specify this as a get request or this is a post request, we can do the same thing inside Express. So we can say get, which means I want to get this value. And that's looking for a get request. So I'm just going to type that out as a function call. The first argument is the path that you want to listen to. So I just want to listen to the root path. So slash, that's literally where we are right now. We're at the slash path. And then this takes a callback, right? So you can write it as function like this, but that's not the common convention. Instead, just like in React, we use our shorthand, or like our arrow function. So we're going to take in a request, a response, and we're going to pass that on. So what happens is this callback is going to get called by React. React is going to match this when the person goes to the home route. It's going to take the request and convert it into an object, and it's going to create a response object as well, and it's going to pass both of those as arguments to this callback, and then we have access to these values inside the function body. We don't really care about the request, so right now we're just going to send back a response. So we're going to say response dot, and we can send back JSON, XML, literally whatever we want, but we're just going to use their send function. And the send function, all we're going to do is send back hello world. Like so. Very simple, nothing too elaborate. Now in your browser, if you hit refresh, you'll get hello world in the browser. So we can get more elaborate as well, just like we could in React. We didn't go that far with React, but we can actually take in parameters from someone. So somebody can actually send us parameters. So why don't we create another route? We'll make it a get route as well. And this one's going to be to greeting. However, we're going to take in a parameter called name. And then this is going to go to request and response, like so. And then we can respond with hello to whatever we want. Now this name parameter actually winds up getting added to our request as a part of its params object property. So the way we can see that, why don't we just console log it out for now. So we'll console log out the request in its entirety, which is going to produce a lot of information, just to warn you. And then to access this, all I need to do is go to /greetings. But if I hit enter, it's going to say cannot get because I'm missing this other piece. I don't have this piece in there. So I'm going to say greetings, and I'll just pass in my name. Oh, that should have worked. Cannot get greeting. Oh, because it's not greetings, it's greeting. It should be greetings, though. I did that wrong. Oh, you see? Now I'm eliminating things. There, try that again. There we go. Now, it will say this same error message up here only because if you notice it's spinning, And when you get that spinning sign, and this happens to students all the time, it means that you have forgot to send your response. And that's exactly what's happened. We don't have a response yet sent. So in here, and I'm going to maximize this is what the request looks like. So there's a lot of information in this request. So it's our incoming message. Here's the rateable state. Here's the events. More events. Writable state. Server state. More server information. Parsers. The on listener. Bunch of symbols that are defined. Our headers, right? So here's all the headers. So the localhost 4000 is where we're coming from. Our connection is set as keep alive. We have cache control set. The user agent, right? So which particular browser you're using. I'm using Chrome. What kind of data types it will accept. So it accepts HTML, XHTML, image formats, all that type of stuff. Any raw headers that have been defined. Trailers, raw trailers. I don't know what those are. I've never seen those before. Any client information that's needed, more event information, more server information. Somewhere in here is our params. There they are. There's our params. There's name, there's Sean. So what it does is it essentially generates a query string, just as if I had typed almost the equivalence to typing that, right? But instead I type Sean and it produces that for me. So now I can access that parameter. So why don't we do that? We're going to do const name equals request.params.name. So now that will be in there. And then we can send our response. And we got hello Sean. And you can have as many of these type of slash whatevers that you want. You can also do it where it's optional and it doesn't necessarily have to be included. I think you just add a question mark in front and then you can make it optional. Or maybe it's after. Oh, it might be here, actually. Oh, I can't remember. There is a way to make it optional, but I totally forgot how to do it. We can look it up, though. And that's the cool thing about it is you can actually look it up on Express routing. Here's our documentation or our textbook on routing. And this walks you through all the different ways to set up routes. So they use kind of standard functions, which is totally fine. Let's see here. There's the standard get. Yeah, you see it does the matchings, pattern matching. There is one where it's a slash and colon. Here we go. So route path users slash colon user ID book slash book ID. There's a way to do optional. You can do ranges as well. Yeah, you know what? I'll do that on my own time. I'll find it. Unless one of you finds it first. All right, so we have our home, right? So we can navigate to home. Hello world. We have our greetings, colon name, which will return back our name for us. And then we can also create another route, which is a little bit more fun, is our Chuck Norris route. So we'll do that next. So maybe we'll just call it Chuck, or you can call it Joke, or whatever you want. And this is going to take a request and a response as well. Like so. And we need to get our response. So we're going to say Axios .get, and I'm going to give you guys the URL for this. So it's https://api.chucknorris.io/jokes/random. And you can just copy that out and paste it in here. And then we'll do .then. So .then happens when a promise has occurred, right? So this is going to return back a promise, and this is going to return back a response. Don't call it response, though, because you'll wind up with a conflict. And then in there, we can go ahead and response.send response.data, like so. When you're done that, you can go to /chuck. And it's going to produce this, which is not the cleanest looking thing in the world. It tells you the categories, gives you the date, the icon URL so that you can look at whatever icon it's produced. Whole bunch of stuff, but you'll notice that one of the values is called value. And my value was Chuck Norris bed sheets are made of sheer metal. That was mine. So if you wanted just the value, you could just do response.data.value. And then you would only get the value. So this type of promise-based dealing with I/O, right? So this is an I/O operation, Axios.get, creates an API request, and because this is considered non-blocking, any code after this point would just be executed. So we want to make sure that we only execute this particular line of code once the API has been reached out and we've received back a response. That's where .then comes into play. That's why a lot of people much prefer async and await. So what async does is basically says, hey, I'm an async function. And what await does it says, I will wait till the async function has finished, and then I will execute my next line of code. The way we use async is we have to make sure the wrapping function, so that would be this function here, our callback, is set to async. So we just simply type async in front of the words request and response. And then we can get rid of the then, so we'll just move this down and get rid of the then and end that. And then we need to type a wait in front of the Axios request. So that will now say, hey, wait for this to finish before you do anything else. Now you'll notice that we don't have this variable attached to anything yet. We need to attach it. So what we can do is we can say const response equals await. And if we hit refresh, we get the same operation. But now it's a little cleaner as it's only 2 lines. And we can get even cleaner if we change response. We know it's going to come back as a response. So we can say data, and we want the value from it. So we'll just destructure it right down to the value. So that returned back value. Why did it return back value? That should have been response. I wonder if I have to wrap this. Sometimes you have to wrap it. Interesting. Oh, I see. Interesting. So it does return back value, but we have to wrap it because it returns it back as an object. So data is actually an object, and we want the value. See how this whole thing is an object? So we need to signify the object, but we only want value from the object. So that'll work. There we go. That's a rude one. Sometimes they're rude. Sometimes they're good. There. Exciting? So much fun. You guys have built your first Node Express server. So let's take it one place further. So right now we're currently accessing our API using the browser here, right? Which is okay, but ideally we should use something that works better with APIs like Hopscotch. So Hopscotch allows us to do API testing. And the way we do it, the first thing we do is type in the URL that we want to test. And yes, you can use your local URLs. It's totally okay. So your local URL should be HTTP. Don't put an S on it, right? Make sure it's just HTTP, ://localhost:4000 and hit send. And you should get a response body of hello world back. If you try your other one, /greeting/your name. So I can't get greeting because it's not called greeting. It's called greetings. I get hello Sean. And if you try Chuck, you get your Chuck Norris response. Now, APIs, as you saw with the Chuck Norris API, don't generally send back strings, right? Generally, they send back some sort of data, usually as a data object, whether it's XML or JSON. So we're going to modify our very small API so that it returns back JSON data. And there's two pieces to this. One is the status. We should send back a status. And these are HTTP statuses, which some of you might be familiar with, like 200s, 202s, 300s, which are redirects, 400s, which are tend to be like request errors, and then 500s, which are server errors. So we're just going to send back a 200, and we're not going to send back hello world in this format. We're going to send JSON, and we're going to add a JSON object in here like so, and we're just going to say message like so. And the cool thing is that we can actually put these on their own lines as well, like so, because they will chain together, which makes it a little bit more readable. And now in Hopscotch, if I check this, you can see I get a message called hello, but you'll also notice I get a status of 200. So this is why it's very cool, because you can actually get more information about your API. Let's go ahead and change the other ones as well. So I want to do a status of 200. And I want to send JSON. And again, I'm just going to do this as a message. Whoops. Like so, and then test it. And it worked. And then in my last one, I'll do exactly the same thing. I'll do a status of 200, but this time instead of sending back just the value, I'm going to let it return the whole data block. So I'm just going to capture data instead of value. And I'll return back data. So that'll be the exact same JSON that basically this returns. So if I test it, it should give me the same thing. Or I'll zoom in a little bit because I just realized it's probably difficult to see. So yeah, you can see my JSON structure here. And the cool thing about this too is if there was an error in here, I could send back a different response. So why don't we try that? We'll just wrap the whole Axios request in something called a try catch. So try catch basically says try this thing, and if it fails, catch the error and do something with the error. So what we can do with the error is we can do a response dot status, and we'll just do a 401 saying that there's an error dot JSON, and we can pass error to JSON, but you won't actually see what it says because error is kind of a weird object that gets produced by JavaScript. So instead we want to kind of like flesh out what it is. So we'll do message : error dot message, like so. And if you wanted, you could do the stack as well and do error dot stack, but the stack is not relevant to the end user. So just do the message. And I'll copy that for you and give it to you so that you have the ability to just kind of copy and paste it. So if I call the check one now, and I hit send, I still get the 200, but if I cause an error, so why don't we say randoms, because that's not the actual path. See, now I get the status of 401, and I get an error message that says the request failed with status code 404. So yes, I didn't send back a 404, but the Chuck API sent back a 404. And say the message didn't come back and you thought it was inappropriate and you wanted to be like, this is inappropriate, I don't want to show it. You could always return an error as well by just throwing an error. Like so. And then if you execute this, it throws a 401 and you get your custom error back as well. So you get some control. So let's talk a little bit about our application. We're using hopscotch here. Nope. I'm doing this thing. This image is super small. I don't know if you're going to be able to see it. Hopefully you can see that somewhat okay. I realize it's really tiny, but you're always welcome to look at the notes as well. So Express represents three major components that we're going to frequently use. The first component is the application object, right? So that's the instance, this thing here, our app, right? This guy right here. That's the instance of our Express application. You use this to register any middleware and any routes. So this is what the syntax looks like when we register a piece of middleware. This is the syntax when we register a route. The request object here that we're passing on is a wrapper of Node's HTTP request object and is used to extract information about the currently handled HTTP request. So when we are actually making a request from the browser by entering in that address, that creates a request object, and then we have access to that information inside the request object. The response object is a wrapper of the Node's HTTP response object and is used to set the response data and headers. So any data we want to send back to the requester is attached to this response object. And we can use its helpful methods like the status method, the JSON method. There's actually a bunch of different methods that we can use in order to attach different things to our response object. So the application object itself, this guy here, it contains a whole bunch of different methods that can help us to configure our application. There's app.set, which allows us to be able to set environment variables that our application is going to use. We have .get, .post, which allows us to be able to create different routes. We have an engine, which is how we would connect up a template engine so that we could actually produce HTML visual things on the front. We get app locals, which allows us to be able to transfer data between different components into our engine, like our view engine, but we're not going to be using a view engine. App.use, which allows us to register middleware. And then we have the app verb, but the only ones that we're going to be using are get and post. There are put, delete, patch and head, but we're not using those in our particular application. There's also the app.route path, so you can actually create a route. This is used to define one or more middleware functions to respond to HTTP requests made to a certain unified path in conjunction with multiple HTTP verbs. So the idea of that is basically that you do app.route and give it a path, and it doesn't matter if it's a GET request or a POST request, it will execute whatever callback that you want. And then there's app.param, which is used to actually attach a parameter to any one of the routes that we're using so that that parameter can be used by that route. Any questions about this? Don't worry if you're having difficulty understanding. We're going to write so many of these, it's not even funny. By the end of it, it should be just as easy to do as React, if not a little easier. No questions? All right. We're almost at break time, but I want to just talk about MVC a little bit before we do break, because it's my one lecture I have. And then what are we doing after that? Are we doing the routing in depth? Is there any actual things in here? I usually save routing for the next class. We'll do a middleware, and then we'll call it a night. So you know what? Let's not take the next break, because we'll probably be done in about 15 minutes. Unless you really need a break. Do you really need a break? Or are we good for 15 minutes? I've lost you all. You've all gone to sleep. You're okay? Alright, let's do this. MVC. What is MVC? Well, you guys already took an MVC class, so you should probably already know what MVC is. Right? MVC, Model View Controller. Probably one of the biggest, most fundamental design patterns that you're going to see anywhere in programming design. I've actually, you know, it's funny. You never stop learning about design patterns. Like, for example, I started at LMG, and I've been using different design patterns for a while. Like, I use MVC, and then I've used MVC, I've used component design, right? Those are two design patterns that are very common. And then when I started LMG, I was like, this is kind of an interesting concept. What's this? And it's called the domain persistence layer, or the tiered architecture layer. And it's like a design pattern where your presentation is entirely self-contained. Everything you needed for presentation layer is self-contained as its own application. So it's not an MVC. It can be an MVC, but it's not. It's usually just a whole presentation layer. Then you have your domain layer, which is like your REST application, right? So that's where your API goes. And then you have your persistence layer, which is like your data. So the REST layer, yes, it might communicate with your persistence layer, it likely will, but it's not actually connected directly to the database. There's another piece there that connects to the database. And I thought that was kind of interesting that it's separated like that. It's a bit confusing, but it is interesting. I love Model View Controller. It's one of my favorite patterns, and I do it all the time. I like to force things into Model View Controller. Like, for example, I got forced to use WordPress once, and my first step was trying to make it more like Model View Controller. But yeah, that's my one example that I have. Anyway, so MVC is a programming pattern that separates an application into three interconnected parts. Your data logic, right? So that's your model. Your presentation logic, which would be your view. And then your business logic, right? Which is anything to describe your application, basically. So the model, right, which is our data logic portion, the model is comprised usually of a few pieces. So I'm going to use this word quite often. It's called resource. A resource is a collection of attributes. You can think of it like a table in a database. It's data points that our application will utilize. This can be an API endpoint, which it usually is, a file source, or most commonly a database table. The resource generally refers to a singular representation, right? So whenever we're talking about a model, we generally refer to it in the singular sense. So instead of users, which should be plural, we refer to our model as user. That's a naming convention, but it is the most common convention out there. Attributes. These are the individual data points. So I will say attributes quite often. Sometimes people call them fields. Or properties. I call them attributes. These are the individual data points a resource is comprised of. So a good way to think of those are like the columns in a database table. Those would be your attributes. So a user would have first name, last name, age, whatever. Those would be the attribute pieces. So Crud is the next one. I use Crud all the time. Hopefully by this point you guys know what Crud means. But for those of you that don't, it stands for create, read, update, and delete. These operations are handled by the model. The model is responsible for communicating to the database and actually directly facilitating creating, reading, updating, and deleting data with the database. Validation, sanitization, and normalization. Sometimes people don't agree. They think that the controller should be responsible for those actions. I believe in a fat model, skinny controller, which means I like validation, I like sanitization, and I like normalization in my model, seeing as how those three particular things are data related. However, I had my eyes opened recently by another senior dev at LMG that was talking about validation and how we tend to over-validate, where we'll actually validate in the controller to make sure that we've received the correct data points that we're expecting. We'll validate in the model, basically doing a validation checking to make sure that the data is in the correct format. It's doesn't contain any unnecessary pieces. But we also tend to validate the data type there as well and say, this is a string and this is an integer. And this password is only 8 characters long. But then we also validate in the database. So we tend to wind up validating in actually 4 places because we're not even including the front end where we likely do client-side validation too. So we have 4 different states of validation, and we need to be a little smart about that. We don't want to over-validate when it's not necessary, creating more delay on our system. But anyways, validation, sanitization, and normalization, that's the model's responsibility. And data formatting. So this is the various ways our data points can be formatted. So for example, often when somebody is accessing user information, they want to be able to display their full name. You don't want to have to take the first name, last name, and concatenate them. Models allow you to create something called an instance method, where you can say, this instance method's name is full name. And when you access it, the model automatically concatenates that data for you, and you're just accessing the full name at that point. So the model has a lot of heavy lifting to do. That's why I like to call it the fat model. It's not a shaming thing. It's just that's a terminology used for them. It just basically means that most of our code base will wind up inside the model. Views. So the view, right, is our presentation logic. This is where the user will interact with our data. So it controls the structures the user will view. So interestingly, the views aren't always in an HTML format. So this is a common misconception that people think views must be HTML and it's only browser related. That is totally inaccurate. You can have views that are not in HTML but might be in JSON data or an XML structure. So a view is really just how the data is being presented to you. That's all it is. So it doesn't necessarily have to be pretty. Sometimes it can just be data driven, or sometimes it can be something like a PDF, right? The view is just the presentation of your data. So there are different types of views. There's your data object view, which is usually in JSON or XML format. These are generally used to control the visibility of data. So if you are getting JSON or XML, there is likely some logic in the background that is formatting that data structure so that you get it in a specific way. Static view, right, which contains no data from the model. This view is for static hard-coded content. So this might be something that the controller has just passed back that doesn't actually have any data points. Or a dynamic view, which is usually in HTML, but not always. Sometimes it's just PDFs being generated or whatever. These views are provided with they provide the user with content generated from the model, right? So data object views, which is structured data. Static views, which contains no data, because it's all hard-coded. And dynamic views, which is dynamic data. And then our last piece is controllers, right? The last letter, C, stands for controller. That's our business logic portion. So it's easier to think of this as being like a conductor or an operator that facilitates communication between our model and our view. So the view never ever directly talks to the model. That's never happens. The model never directly communicates with the view. You need the controller in there to deal with those two pieces. User fills out a form in the view, submits it. The controller takes that information, passes it to the model. The model inserts that data into the database, tells the controller everything is great. The controller tells the view to update that it now has data. And that updates. The controller has quite a few responsibilities depending on the business requirements. So, interpret the view's request, which I just described. The controller receives communication from the view, and it does all the heavy lifting of data operations, right? The model does the heavy lifting of data operations, but the controller is the one that facilitates it actually performing those operations. So the controller says to the model, hey, go create this record, hey, go delete this record, so on and so forth. The controller interacts with the model and communicates with it. It does not mutate data. The controller does not mutate data. It does not validate. It does not sanitize. It does not normalize. It does nothing with the data except for what it might do is ensure that it has the correct data before involving the model at all. So it might take a look at the data the user has passed and ensure that it has the correct pieces of information before it actually involves the model. And then interacting with the view, the controller is responsible for telling the view to update or render. So there's some social conflicts when it comes to MVC. MVC, it's an old design pattern, and there is a ton of opinions out there about how it should be done. It's utilized in a lot of popular frameworks, such as Ruby on Rails, which was one of my favorites. Laravel, for those that enjoy PHP, or CodeIgniter and Yi, which are also PHP ones. Or .NET MVC, right, is another big one. Or the one that we're going to create on the fly, which is using Express. However, interpretation of what exactly a model view controller's role is in a pattern seems to be plagued with controversy. Some believe the controller is responsible for the majority of operations, such as validating, sanitizing, normalizing data before it reaches the model. This has led to the very popular, and you guys can look this up on the internet, fat model versus fat controller controversy. Where should the majority of our logic dependencies reside? So obviously, like I said, I have an opinion on this as well. I'm of the mind that the data, anything data-driven, anything data-related, should be handled by the model. So the controller shouldn't be aware or even care about the format of the data or whether it's valid. It should, however, care that you pass the correct data points to satisfy the model's requirement. There is a case study here that you are welcome to read if you want to. I'm not going to just because of time, but you are welcome to read the case study there. Or not care, because I have a funny feeling most people don't care. They're just going to do whatever the company that they work for dictates, right? So if they say fat models or fat controllers, then I guess that's what you're using. REST and MVC framework. So representational state transfer is a pattern used for API systems. The idea is that it uses HTTP verbs, so get, post, put, patch, delete, head, there's a whole bunch of them, to understand what a request is asking for. So it's looking at those verbs to figure out, are you reading data? Are you writing data? What are you doing with this data? There are several HTTP verb methods that can be used, but in our application we'll only be using get and post. The reason being is that the browser generally only understands get and post, even though Express understands them all. We've already talked about get, that it's used to read data. We've already talked about post, that it's used to manipulate data. It is important to understand that MVC frameworks aren't just models, views, and controllers. There's a lot of other running pieces and processes involved. A lot of people think, as long as I understand what a model, a view, and controller are, I'm good to go. But there's so many other little pieces that are working in there. For example, many model view controller frameworks also involve an ORM or an ODM, which stands for Object Relational Mapper or Object Data Mapper. These are systems that basically take databases and map them into models so that we can easily treat data as an object and understand that this is an object that contains attributes and that we can access those attributes. And creating and reading and deleting and updating are just common operations on any data table, and therefore they can be abstracted into like a base class that we're inheriting so that those operations aren't something that we have to define each time. ORMs and ODMs, definitely learn those. They definitely make your job much quicker and much faster. We will be using an ODM in this class called Mongoose. That's the system that we'll be using to communicate with Mongo. Naming conventions. Naming conventions is simply just how something is labeled, but it's a very common thing to understand. For example, a user represents one user. It also represents a model, right? It's a singular form. Users, with a plural, represents one or more. That type of terminology I will be looking for in your projects and your labs, that you're using the right naming conventions. And yes, it will be penalized with lost marks because those naming conventions are super important in helping other developers understand what you're writing. Many ORM and ODM systems actually provide inflection, which is essentially just a fancy term for using plural and singular formats, and they enforce it. So in Mongo, for example, if you don't use user and you were to use users, it would actually cause errors. Same with controllers. We tend to use the plural convention when we're referring to the controller. So we would have a user model, but users controller. And views are often named after the controller action they belong to. This obviously makes no sense yet, but it will make sense when we create our first controller next week. So controllers essentially house all of the actions that you're going to do, right? So when a person sends a request to create a new record, that request goes to a controller action called create. The controller action checks and makes sure it has the data. Then it actually fires off to the model that it should create the new record. And then it sends back to the view that it happened, and here's the results. And then one of the most important fundamental parts of MVC has to be routing. Routing is definitely one of the most fundamental parts, as it deals with the requests coming in and what is happening with those requests within our MVC. So routing, ORMs, naming conventions, and also folder structures, right? Making sure models are under a models folder, controllers are under a controllers folder, and views are under a views folder. Any questions about any of that? We don't have a lot of lectures in this class, but we have a few. We're going to talk about routing in depth next week. Middleware. What is middleware? Well, middleware are actions that execute upon a request during its life cycle. So the life cycle is when it enters our application, right? Which is kind of funny because it actually enters down here, right? The listeners listening, it enters into the application, comes through our app, and then our app starts applying middleware to it right off the get-go. So the first middleware we're applying to our request is the use cores. So that gets applied automatically to our request. Then we start going through the rest of our middleware. These routes are still technically middleware as well. We can actually effectively format and modify our request as it's going through the middleware and add other things to it or take things away. We can also validate information as it's going through our requests. So how do we write middleware? Well, middleware is actually pretty easy to write. All we do is say app.use, and then that takes a callback function. In that callback function, we get the same pieces that we get with a route middleware, except for I'm going to add the third argument called next, and that's super important. So I have app.use. Here's my argument list, request, response, and next, and then I'm funneling that into here. So all I'm going to do in here is just say console.log. I'm going to run on every request. And that is true. Because we use app.use, this is literally going to execute upon every single request that we process. Now, it's super important because I'm not responding here. I don't want to respond yet. I'm not ready to send the request back to the browser, or the response back to the browser, I need to tell it to go to the next middleware. So the way I do that is I use next, and that actually tells our request to go off to the next middleware and be evaluated. So if I go to localhost :4000, oh yeah, I can actually go over there. That's fine. We need, there we go. I want you to view down here because that's where our console is going to come out. I'm going to navigate to localhost :4000. I'm just going to remove Chuck there, and I'm going to hit enter. And as you can see, yes, I got my hello world, which means we actually hit this request right here. But I also got the I'm going to run on every request. So that's this middleware here that actually executed. So what happens if you don't want to execute upon every request? You only want to execute on specific requests. So we can do that as well. Say we only want to output something when somebody posts information. Well, I can do that by just restricting, by doing app.post. So now instead of this being on every single request, it will only do it on post requests. There we go, and I'll just say console.log. I only output on post requests. And then we have to make sure we do next, otherwise it won't continue. So now if I want to post this, that's totally fine. I just go to post, change this method to post, and hit send. And it says I'm going to run on every request. But it didn't run our post request. Why didn't you run the post request? You should have. Oh, I got a 404 actually. That might have been why, because I got the 404. But it should have picked up on the post. That's super weird. It might be because of the 404. Let's just try app.post. We'll do it properly. Status of 200.json. There. We'll try that. It might be because it didn't complete. So we'll send it. No, it's actually just avoiding that one altogether. I think I might be wrong. I think you might still have to do use. And that's why. But you can define it so that only runs it based on a pattern as well. So you can give it a path so that it only run on that. So this will be only on API requests, which means if I do /API at the end of this request and hit send, it says I only output on API requests. But, whoops, I didn't mean to do that. But if I take the API off and hit send, I'm going to run on every request. Did it literally just do I'm only running on API request again? See, I can't tell. This is just making me out to be a liar. Nope, it's only running on that one. Yeah, it's not running on the API request. So I'm pretty sure you can do app.post and only give it a thing, and it will actually funnel it only for app.post. I might have to look that one up, but that's basically essentially middleware. So why is middleware important? Well, the reason we have middleware in the first place is so that when we're doing things like authentication, the middleware will actually stop in the middle of our request cycle, allow us to be able to authenticate the request and make sure the person can actually perform the operation they're trying to perform before we send it off to our very sensitive controller, right? So this allows us to be able to kind of block it, deal with it, and then move it on. There is a ton of middleware that we're going to actually introduce into our applications that also provide things like sessions, They provide a body parser, for example, for actually converting form body data into JSON. There's a whole bunch of different ones that do different things that are very important, including authentication. So middleware is a key fundamental part of our whole process. Yeah, so that's basically it. There is more in here, but we're going to do that next week anyways, so I don't want to do it now. Is there any questions about any of the stuff we learned? So there's no labs or quizzes tonight, but what I would recommend doing is create yourself a small Node application and just get comfortable with creating routes and using paths, and maybe review the routing information, like the routing documentation. And use Hopscotch. Hopscotch is a great way to do it. If you want a more professional tool set, use Postman. And that's it. I have nothing else for you.